The microphone started again. Here we go. Wrong way. Reference angles we talked about on Friday. This was the new page from today that you guys were hopefully writing as you finished your quiz. Let me get out of that and get to a single page again. Reference angle basically asks, great, so we have this angle that's over 90. So if it's not over 90, we're just making a triangle with the first quadrant. But if it's something over 90, that angle is obtuse, is getting bigger than 90, and yet we can still think about a triangle with a little acute angle, which is what we think of when we have something like 135 degrees. We think 45-degree triangle because the reference angle would be 45. Now, a couple things about reference angle. Remember, first of all, it's always positive. It's always measured to the horizontal axis, the x, never to the y. Always to the x, never to the y. And even though you're talking about, or we're going to be referring to little baby reference angle, we still have to think about what quadrant are we, and so what sign should we be thinking. So for instance, if we had somebody in the second quadrant, even though we might be thinking about as a little baby reference angle, what signs should our trig functions have in the second quadrant? Negative, positive would be like the coordinate. The x is negative, the y is positive. What does that mean? Or how does that translate to what the signs of the actual trig ratios will have? Come on, how'd you figure out how to make a negative or positive? What's going to be positive? Okay, so sign is going to be positive. Who else is going to be positive? Just sign and his reciprocal. Who is who? Cosecant. So sign and his reciprocal. Sign and cosecant are both going to be positive. Everybody else, negative. Cosine's negative. His reciprocal, secant's negative. Tangent, y over x, he's negative, and cotangent, he's negative. What was the silly way of remembering second quadrant? Only sign and his reciprocal are positive. Students. Exactly. Students. Good team.
So if we're in the fourth quadrant and we have a reference angle, would we just ignore the negative and make it positive?
The reference angle tells us what triangle to look at. But the angle itself, ending in a certain quadrant, tells us what sign to keep.
So if we started with the negative angle and then went this way, how would we draw this, or draw the triangle for that?
We would still draw the triangle. What interesting is, what if you had like a negative, like we had in the quiz, like a negative pi over 3, for instance, or negative pi over 6, whatever it was. Negative pi over 3. A negative angle. Your reference angle would just be, as they called it, theta prime, or as I call it, alpha. Let's say we were going like negative 30. The reference angle would just be a positive 30.
Okay.
But you still have to use the fourth quadrant signs. Does that make sense? Okay. Let's keep going. Oh, stop. Sorry.
Sorry.
Dual page?
5 more seconds.
So the reference angle has to always be positive, hence why we couldn't just steal the negative. Has to be something acute, which is why for this one we wouldn't take the theta, we would take the theta prime. And my hint is always watch out for the signs. So some of you have been doing reference angles already every time you do the unit circle. Because I give you something like 5 pi over 6, and you're like, ooh, that's a pi over 6 one, but in a second quadrant. You're already thinking of a reference angle. You're thinking of what's that little bit left over. Or if I give you 7 pi over 6, you're like, oh, how much extra is it? Oh, pi over 6. Some of you have already been thinking about reference angles, just you haven't had an actual name for it, at least not that you remember. How about now? We good?
Yes.
Ready, set, go. Okay. So, let's have some fun. 300 degrees. What quadrant?
4.
Uh-huh. And someone already answered the reference angle. How'd they already figure out that it's 60?
Subtraction.
Uh-huh. Because 300 degrees is a little shy of
360.
So if we subtract it, we get the reference angle, which is 60. So we can say, I'm just going to use alpha. Beta prime is weird. Reminds me of calculus, and it doesn't have anything to do with calculus. So alpha is equal to 60. Oh, guys, this is easy. All right, you guys do letter B. It's not a very big number. You don't have to convert.
Wasn't it in reading?
How could you write the answer without converting? Wait, why is Andrew talking about converting? No degree mark, it's a radian. Remember, radian. Measuring arc length, measuring around the circle with radii. Think of a circle, cut its diameter in half, measure around. 2 something radians is going to be in what quadrant?
The second.
The second. Because how many radians does it take to go all the way around?
18.5.
Second.
All the way to the semicircle.
Oh,
3.141596. So where's 2.3? I don't know, here-ish. Okay, so here-ish.
Oh, it's here.
So much judgment. Okay. How did I figure this guy out? If this is 2.3. From? Yeah. Dun, 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 dun. Dun, dun. Look at you guys thinking that I needed decimals. I don't like decimals, remember? So if you can't do them, or if you don't want to do them, or if you shouldn't do them because it'll introduce error, then don't. It's just pi minus 2.3. My alpha was a little funny, don't judge. Now, could you have taken 2.3 and could you have multiplied it by 180 over pi, and could you have then, I suppose, but that sure seems a whole lot more difficult than it had been. Negative 135.
45 degrees.
It is the third quadrant. Caro is right. It is 45 degrees. Because...
180 minus 130.
Exactly. Oops. That's too far. Cool. Negative 135, he's a little bit shy. How much shy? 45 shy. Now, what if I was to do a really fun one? And give you something like, well, I don't know, I thought the 2.3 was kind of fun. Not because you got it wrong, that's not how I find a problem fun, but because it made you think. Okay, letter D. How about theta equals negative 500 degrees.
40 degrees?
240.
That's second. 240? That's the second point. No, that's not the second point.
Yeah, I agree.
That's the third
40,
quadrant.
and it's the second quadrant. You're wrong.
Is it third quadrant? It's the third. It's the third quadrant, Colby. Are you forgetting there's a negative?
That's right.
So it's 40. What? Are we all confused?
Okay, what'd you do? Jonathan is very confident. What'd you do, Ben?
Okay, so I just subtracted 500 from 360.
yeah.
Or you could add it. Add it?
Which is?
140.
Now what?
And then you put a negative on the 140. There we go.
So my negative 360, I have another negative 140, right? Is that okay? Now what? Subtract from what?
180.
Negative 180.
You said I need to figure out the difference between 180 and 140, true? And the reference angle is always positive, so hence the 40 degrees.
I did 360 times 2.
We want big triangle.
320, then 360 minus 40.
And then he added 40 to it.
Hold on, guys, let's figure out how Janelle's way works too. So she figured out 360 times 2 is 720. So she was thinking of 2 full rotations. Oh, it's not quite big enough. 720 minus 500 is 220. Ooh. Oh, it'd be 220.
Never mind.
But somehow it still ends up being the right way.
Way to go.
Like, you would have thought of, let's see, 720 would be going all the way around. Subtract 500, that would get this one, which would be 220, which is 40 past 180. That could have worked. So you could have thought of, okay, 220, but I'm 40 past 180. So you're kind of going the backwards route of what's missing instead of what's there.
Yeah.
That works too. Just careful. Are we good at reference angles?
Yeah.
Look, he's just going at it. No idea what he's going at. All right. How about these ones?
Oh.
Oh, you're just evaluating. So why on earth is this in the reference angle section, you think? Because you kind of have to think of the reference angle in some way, shape, or form. Cheater chart, don't you have to think of this as a 60?
Yeah.
Right? Or pi over 3?
Did anyone use
Triangle people? I saw how many people wrote the cheater chart in some version on their test. How many people drew a circle or some quadrant or piece of a circle on your... See, it's like half and half.
That's like.
How many people just did triangles?
triangle?
Oh. How many people just visualized over a lot, over a little, over...
Way to go, John. Way to go.
Some people did, who did a combination of some of the above?
Yeah.
All 4 on tree, literally nothing.
So these ones, at least in some way, shape, or form, you have to think about the reference angle, right? So kiddos, it shouldn't be a big, big, big deal. Who's already gotten cosine of 4 pi over 3? Janelle. Do you guys agree? Negative and half?
Yeah?
Good job.
Something alright.
Okay, negatives. Thomas is already like, I don't like negative positive thing. Ready? Hold on, pause. 4 pi over 3. You have 1 in the third calzone, right?
Yep.
So 1/2 fold of pizza, and then you have another third. You're in the third quadrant. Remember, your x is going to be negative, your y is going to be negative. Whose cosine? He's an x. Okay, he's a negative. Whose sine? Your y. He's a negative. What's tangent? Negative over negative, which will be positive. Another way of thinking about it is a negative and a negative. Cosine's negative, sine's negative, tangent and cotangent will be positive. Another way of thinking about it, all students, only tangent and his reciprocal are positive, the rest are negative. Who already has tangent of negative 210?
That was
Oh
weird.
my gosh, that
That was
scared
I don't know what
me.
that was, that was fun.
Let's
A magnet though.
Let's leave. That's no treat.
Negative 210, where are we at, cool kids? No, second quadrant, with what kind of reference angle? 210 minus 80, or 180, sorry, is 30 degrees. It's a 30-degree reference angle, which means it's a pi over 6 if you're thinking in radians more than degrees. Awesome. But, God needed both.
I think in range.
So it's 5 pi over 6 now.
Go on.
It's over a lot, root 3 over 2, up a little, 1/2. It's going to be a negative, and it's the little over a lot, so it's going to be 1 over root 3 or
Rad 3 over 3.
negative root 3 over 3.
What does it mean what that makes sense?
People in the cheater chart, it'd be a 30-degree or it'd be a pi over 6 one, which would be rad 3 over 3. Cosecant of 11 pi over 4, where are we at?
Way away from home.
There's 4 slices, there's 8 slices, we need 3 more.
You just said 270.
What? 270?
Rad 270.
That's what I say.
Oh.
So it'd be 1 pi, 2 pi, can't you think about this as being 2 3/4 pi? Or you can also translate it, sorry, convert it to degrees.
Wait.
So wouldn't it be 2 pi to the 3/4 pi? You're at a 45-degree reference angle, right? Cosecant is 1 over sine.
Negative rad.
No, cosecant is 1 over sine. Sine is a positive in the second quadrant, right? Yeah, sine is positive. So it's just rad 2 over 2, which is 2 over rad 2, which is 2 rad 2 over 2,
So
which is rad 2. This is the one time it's a lot nicer to think of this as 1 over rad 2, because then you flip it and you're done. But that's
So intense.
wow.
You know who it is?
Dun, 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 dun. We are not, I don't think, doing that. Let me check the calendar real fast.
Oh my gosh. It's me.
Hold on, I'm checking.
Is 4.5?
4.5 goes into graphing. I did not make the calendar before class today.
Is 4.5 gonna be due on Thursday or Wednesday?
When do you think fifth grade?
Well, I have to close out this grading period before I can put any new grades in, which means I have to wait until Wednesday to put any new grades in. Yeah, guys, you're good. I just freaked you out for nothing.
Okay, good.
I freaked you out for nothing. We're going straight to the test.
Oh, wait, Miss B, 4.5 gonna be on Wednesday or
Okay. We are going to be transitioning though in some senses. 4.1 to 4.4 was a lot of triangle, a lot of memorizing in the sense of like unit circle, a lot of radians, a lot of degrees, a lot of angles. In section 4.5 and 4.6 and 4.7, we're going to be talking about sine, cosine, tangent in different ways. We're going to be talking about their graphs of the function. Not where they come from, not the unit circle, but the graphs of the functions. Because sine and cosine, they are the shape of any wave. Waves, this will be fun. Amplitude, things like that. Anyway, so finish up 4.4 so that we can transition tomorrow. And I forgot, I never taught you guys the song with the cheater chart. Maybe I'll show you that tomorrow too. Bye, everybody.
It's easy.
No, if it was Mr. Strike's class, you would have just given us the 100 and apologized.
Bye,
Sorry,
Gracie.
guys. Is it kind of like David?